So now let's look at the class B. We have a class B of 172.16.0.0/16. And we have to subnet for this topology.
Nance, sorry, please, can you allow us to record, please?
All right.
Thank you.
Right, so we have this topology.
Oh.
How many networks do we have on the board? How many networks? Who can tell me?
7.
7, good. Seven networks. The point-to-point networks obviously will need 2 IPs.
Please, can you please explain why 7? I wasn't here, so I'm sorry for taking you.
This is a point-to-point network. It's a network. 1. This is also a point-to-point network. 2. Another point-to-point network. 3. And this network is 4. This network 5, 6, and 7. Are you clear, Boo?
Yes, please.
Right. Nana, did you say something?
Yes, I wanted to ask that question and he asked it, so it's clear now.
Okay. So now let's do it this way. For this network, we need 79 users. Over here, let's assume we need 206 users. Here we need 49 users. And over here we need 841 users. You see, let's try this. Let's have fun with this. Variable length subnet mask. So you write down your equation. Network bit plus host bit should give you 32. 2 raised to the power h minus 2 should give you the number of users. Now let's take it network by network. We are taking the first one here. 2 raised to the power h minus 2 is equal to 79. 2h is equal to 80, my 8 again, 81. Our try and error. I know that 2 raised to the power 6 is 64. There are certain things you have to know before you attempt to approach this type of questions. 2 raised to the power 6 is 64, less than 81. So we move to the next integer. That is 7. We have 128. 7 is acceptable, so my h will be 7. If my h is 7, n plus 7 is 32 from equation 2. My n will be 32, take away 7, and that will give me a subnet mask of 25. So for the 79 users, I need a /25 to make it work. Then I move to the 206 users. Don't be scared of the huge numbers. They are just numbers. If you are scared of numbers, if you see a tiger, I don't know what you do. If you see a tiger coming, I don't know what you do. 206. 2 raised to the power h is equal to 208 because the 2 will go there to add up. Now we come to our try and error. We just saw that 2 raised to the power 7 is 128. So let's start from there. This is less than 208. So we move to the next integer, that is 2 raised to the power 8. That will give us 256, isn't it?
Correct.
Yeah. So 256. Do we accept the 8?
Yes.
So h is equal to 8. So n plus 8, 32, according to equation 1. Our n will be 32, and it's 8, and n will be
24.
20 what?
24.
24. So for this, we need a /24. Then the next is the 49 users. Two raised to the power h minus 2 is equal to 49. 2h will be 51. And 2 raised to the power 5 is 32, which is less than 51. So we move to the next integer, that is 6. That will give us 64. So we choose 6. So my age is 6. So n plus 6 is 32. N is equal to 32 minus 6, and n is at 26. So for the 49 users, I need this subnet mask /26. Then for the 841 users, 841. 2h is equal to 843. Let's do our try and error. So we just saw that 2 raised to the power h is 256. We just saw it. So we start from there. It's less than 846. We go to the next integer. That is 2 raised to the power 9. You only multiply this times 2. And that will give us 512. That is still less than 843. So we go to the next integer, 2 raised to the power 10. We're going to multiply this whole thing by 2. And that will give us 10 and 24. I think our h should be 10. This is not difficult at all. If you see the huge numbers, don't get scared. N plus 10 is 32. Equation 2. Our n is 32 minus 10, and n is equal to 22. So for here, we need a /22. We don't have to worry about solving the 2 users. We know that they are all /30 each from our previous experience. Hello, are you there?
Yeah.
All right. So now the next step is to write down all the subnet masks. Let's start from /30. Then the next higher or the next lower is 26. So /26. Then /25. /24. And /22. Then we should know their block sizes. Block size for /30.
6.
Is it 6?
6. Hey, sorry.
4.
4.
4.
Block size is 4.
4. Yeah, for 30 is 4.
4.
Okay. So we are borrowing from /16, isn't it?
Yes.
/16, we have to borrow 14 bits to arrive at /30. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You don't even need to count. Every /30 has a block size of 4. Okay? Every /30 has a block size of 4.
That's a block size.
What will be the block size for /26?
64.
64.
64.
64. So assuming you are borrowing from a /24, it will still be the same as borrowing from /16. That's for the block size. So you need to borrow 2 bits, just 2 bits, 1 and 2. So 64. What about 25? Block size for 25?
1 to 8.
1 to 8.
1 to 8.
What about 24?
Huh?
1.
Beautiful. The block size.
24.
Mr. Chofo,
Yes.
please, are we working in class B or C?
Class B.
All these are classless. We chose this class B. Okay, so we are the mother class B. Okay.
Okay, okay, thank you.
Yeah, but the resulting subnets are classless. All right.
Okay.
So /24, Nana, what is the block size for /24?
It's 1.
It's 1.
And it's 1.
Why are you teaching?
1.
Nana, are you sure it's 1?
Yeah, 1.
Nana, are you sure?
Mr. Chofo, why is it 1? Why is it 1?
You don't know that it's 1. And when they said it's 1, you also said it's 1.
No, because 24 is class 4.
It's not class 4.
Oh.
In this case, it's not class 4. It's classless because the original class was a /16. So this
Okay.
is not class 4. Not every 24 will be a class 4. You understand? Take notes.
Okay.
24 isn't a class 4. It's a classless. Because borrowed bits. Anytime you borrow bits, you will arrive at a classless address. So the original class was /16, and we borrowed how many bits?
48.
How many
Hey,
bits?
who is that? Who is that?
Hey.
We borrowed 8 bits, eh?
Yes.
All right. Please, somebody's phone is disturbing. Somebody has a noisy background, please. So since we borrowed 8 bits, let's count. 1, 2, 3, 4, 5, 6, 7, 8. The first one, the 1. The block size.
Oh, so 1.
Yes. So take note. It's 1. And what about 22?
Oh.
What is the block size for slash 22?
4.
It's 2.
64.
64.
Hey. How?
64.
It's
So
64.
64.
4. 4.
64.
64.
You
It's
mentioned
64.
4. And yes, 64. How?
We are dealing in
It's
class
64.
64.
It's 2.
It's 64.
64.
It's 64.
Are you sure?
64.
Yes,
Yes,
64.
64.
Yes, 64.
Why is
How 64? 4.
64.
Boss, but where there? When I charge, why?
It's 64.
Because if it's
You
class
borrow
B,
2 bits.
who
no,
told
you are
you?
not borrowing
2
2
bits.
bits.
Who says you are borrowing 2 bits?
You are not borrowing. It's like you are borrowing. I think.
Oh, it's 4. It's 4. Yeah, it's 4. Yeah. You borrow 6 bits.
Yes, 4.
Not. Me sure say in your break.
Okay.
64.
And when I say
think
64,
No, it's 4.
Obobi says
It's
64.
4. It's 4.
Obobe is
It's
not
4.
64. You are borrowing from a slash.
It's 4.
We are borrowing from a slash 16.
16. You borrow 6
Yeah,
bits.
6 bits.
Remember 6 bits.
And if you count 6, 1,
Maybe 4.
3, 4, 5, 6, it's 4. Not 64.
Yes.
All right, so with this information, we need to write down the possible sum.
1, 2, 3, 4, 5, 6. So you borrow 6 bits to this.
With this information, we will be able to write down the possible subnets. Over the slash 30, the first subnet, we are using this. And mind you, slash 30 is in which octet? 4th octet. Take note of this point. So the increment will be in the 4th octet. 0.0.
And this is the problem.
172.16, 0.4. This shouldn't be a problem. Slash 30 can be found in the 4th octet.
Octet.
So the additions will be in the 4th octet. Okay, it's as simple as that.
Okay.
16, 0.8, 172, 16, 0.12, and so on and so forth. All of them are slash 30. Slash 26. Which octet is slash 26 in?
It's in the 4th octet.
So the 64 will increase in the 4th octet. So 16, 0.0 is always a 0.0. Then we go to 16, 0.64, 172, 16, 0.18, 170, 0.190. And what will be the next one? Who can tell me? Plus 64 will give us what? 192 plus 64.
256.
So do you write 256 here? You write 256?
No.
What do we write? Watch here. 1, 0. 1 and dot 0. Take notes. Then you continue from 1.64 and keep on counting and counting and counting. Take notes, okay? All right, so all these things here are slash 26. And the 25, the block size is 128 and it's in the 4th octet. So the first valid subnet will be 172, 16, 0.0. 172, 16, 0.128. What will be the next one? 128 plus 128.
256.
256.
So it will be 1.0.
1.120.
So we'll have 0.1. 1.0, sorry.
Okay, please say dot instead of point.
Okay, sir.
So 172.16, 1 dot, another 128. You keep on adding inside the fourth octet. 16, 2.0. You see how it goes. Keep on adding, you still add in the fourth octet. What about the /24? With the block size of 1. /24 can be found in which octet?
The third octet.
Beautiful. Third octet. So we have 172.16.0.0, and the increment is going to be 1 in the third octet.
Third octet.
So please take note. For a class B, you can at times you can have some in the third octet, some will also be in the fourth octet. So take note. 3.0. All these are subnets. Okay, they are subnets and they are all /24. What about the /22? It's also in the third octet. /22 is also in the third octet. So 172.16.0.0, 172.16.4.0. Take note. 172.16.8.0, 12.0. Now we are left with the choosing. So if you are choosing, make sure that the IPs don't overlap. You don't choose overlapping IPs. So starting from the /30, we have 3 /30. So 1 will be given to this point-to-point network. 192.168. Sorry. 192. Sorry. It's a 172.16.0.0/30. The next /30 will be given. So in this case, we are canceling out all the .0s. It can be used again. So the next 172.16.0.4/30 will be given to this point-to-point network. And the valid IP addresses will be 0.5 here and 0.6. Over here you have 0.1 and 0.2. This will be given to the next /30, 172.16.0.8. So the available IP addresses are .9 and .10. Okay. So we come to the /26. For the /26, the next available is that. So 172.16.0.64/26. That will be the network ID for this subnet. So from this, we can derive our valid IP addresses. And so on and so forth. Please, are you there?
Yes, we are here. We are here.
So there's no other symbol there. What about the /25? /25, that is the next available for the /25. So 172.16.0.128/25. Yes. Then we go to the next. That is /24. So this is available for the /24. So 172.16.1.0. That is available for the /24. Then what next? The /22. This is available. 172.16.4.0. We are done.
Hello, Nat.
Very, very easy.
Yeah. Hello, Nat.
Yeah.
Hello. Yeah. Under the /26.
Yeah.
Okay. We have a valid IP address of 172.16.1.0. Why is it we can assign?
Come again. Yeah.
Under the /26.
Yes.
There's an IP address there, which is the 172.16.1.0.
1.0, where is it? /26.
Under the /26, yes.
This one?
Yeah.
Did I say you can assign it? Okay.
When you assign it,
once you have chosen this one here, the next one becomes nullified. You can't assign it. So with the class B, if you are selected, you have to be very careful.
oh, okay.
Yeah. You can assign it. Is that okay?
Yeah, it's okay. Sure.
All right. Any other question? All right. So now I'm very sure you understand it fully. I can give you my assignments for you to do for me now. Okay?
Hello, sir.
Yes.
Let me come in again.
Come in.
When you assign the IP addresses to the network, okay, you first choose the mother IP address first. Is that also? Unlike you go on to do the /30, you started with a 172.16.0, meaning you have to cancel all out. Then you go to the next one, the /26. Is that what you have to do first before giving the other client IP address? Or
Okay, Obobi,
I get it.
All these are subnet IDs. They are not IP addresses. Now you have to know the difference between IP addresses and subnet addresses. Okay, IP addresses are the usable addresses that can be assigned to devices inside a subnet. So all these are subnet addresses. Are you aware?
Okay, yeah, I'm aware.
Yes. Does it answer your question?
Yeah, it answers my question. But what I mean is, before you putting up the subnet addresses or the IP addresses, right? As you have done right now, you went to pick the 172.16.1.0 to the let's say the 206 users, not the 206 users. Okay. Whilst the same IP address falls under the /26, which gives us this the same marks there. And you say we can't use it because since it has been used under the /24.
Okay, so this one, I was just writing down the possible subnet IDs. After I ended up using just one. You understand? I was writing the possible subnet IDs. So you have to, first of all, write down the possible subnet IDs. Then you carefully come and select, making sure that there's no overlapping IP addresses. Okay, so for the fact that I've written it here doesn't mean that I definitely have to use it. Is that clear?
Okay, it's clear. Thank you.
Nat.
Yes.
What are the valid IPs between? Let's go to /24. Between 172.16.1.0 and then 172.16.2.0. The incrementer, will it be at the 4th octet? So will it be 172.16.1.1 and then .2 or what? I'm a bit confused.
Are you talking about this network, the /20?
Yes. Yes.
Oh, you always start from the extreme right. So the valid IPs will start from 1.1.
1.1, 1.2.
1.2 till you get to 1.25. It's a slash 24, so you are going to have a maximum of 254 valid IP addresses.
Mm.
You understand?
Yeah, yeah.
Is that clear?
Yes.
Any other question, please? And won't you answer the question?
Mr. Chaffo,
Yes.
no, please.
Meaning you will score everything that I'll give to you. Let's clap for Nana. Let's clap for Nana.
Hey, please, I beg you.